worksheet number 11 for 2025 academic decathlon in mathematics. And this is worksheet 11 dealing with the Pythagorean theorem. Pythagoras was a mathematician who kind of created geometry. So these are our warm-up problems. These are radicals, square roots. We know it's square roots because we have this sign. When there is no number, typically there is a 2 in there. That would be a square root. This would be a cube root. This would be a fourth root. And we know at this point what gets rid of a square root is a square. The inverse of squaring is square rooting. The inverse of square rooting is squaring. So we want to see if we can write that as a square, the multiplication of a number times itself. And 256, I'm pretty sure, is 16 times 16. Let's check it out, yo. 16 times 16 equals 256. So that means we can write 16 times 16 is 16 square, and the square will now cancel the square root, leaving us with 16. So the square root of 256 is 16. We call these perfect squares. These are actually rational radicals. Square root of 81, we memorize that. That is 9. Square root of 64, we memorize that. That is 8. You should pretty much know perfect squares up to 20. Outstanding students would know it up to 25. And then you'd also know your perfect cubes, probably up to 5. Outstanding students would know it up to 10. So there's your little warm-up. Here's your second part of your warm-up. Now, when we have orders of operations, we have items being squared and then added. We're always going to do exponents before addition. So we will simplify both of these individuals. 8 squared. Remember 8 squared. 8 is the base. Of course it's happening. Hello. Oh, yes, she is. Very happy to hear that news. Bye-bye. That person thinks I'm a crazy person. And you get to leave. And you get to be on my video. This is in the video. Somebody's going to have to listen to this conversation when they're learning. Poor academic decathletes. 8 squared, 8 is the base. 2 is the exponent. That is multiplying the base times itself, the exponent number of times. So we have 8 times 8, which is 64. And 2 times 2 is 4. And that gives us 68. 11 squared is 121. 5 squared is 25. And these are those perfect squares that we were just mentioning that we should know by heart. And that gives us 146. Have fun. Hopefully they're not pulling any teeth. That student said, no, they're not pulling teeth. 7 squared, 49. Now, here's a crazy thing. What's the base of this exponent? 2 is the exponent. What's the base going to be? Is it -3 or is it 3? It is only 3. There's no parenthesis. Chewbacca is not holding the negative with the 3. So we have 7 squared minus 3 squared. 3 squared is 9, so we have 40. So be careful of that. There is a huge difference between -3 squared and the quantity of -3 squared. The base of this exponent is 3, so this is the opposite of 3 squared, just like the problem we just saw. And this is the base now is included, so we have -3 times -3, which is +9. Very, very important. Now we go into the heart of this worksheet. We have triangles. Triangles have 2 legs of a right triangle. Pythagorean theorem only works for right triangles. So the first thing we should notice is the right triangle, and we should notice the legs of the right triangle. And then the side opposite the right angle would be called the hypotenuse. So we have a leg, and then this is called the hypotenuse. So the hypotenuse is always going to be the side opposite the right angle. The legs are always going to be the sides of the right angle. Now Pythagoras says, hey, in all right triangles, a squared plus b squared equals c squared. Many students memorize that, know it, are familiar with it. A and B are always going to be the legs, and C is going to be the hypotenuse. So it's the sum of the squares of the legs will always equal the square of the hypotenuse. Kind of cool. Interesting. So now we fill in the information. One of the legs is 8, the other leg is 15, and it should equal the hypotenuse, which is now W in this example. So 8 squared is 64, 15 squared is 225. 15 times 15. Oh, I was not being a hypocrite, meaning I knew my perfect squares. 64 plus 225 is 285. Not a perfect square, but that's okay. So we want to solve for W, but it's being squared. What gets rid of a square? Yes, a square root. Very good, class. So that will cancel, and then we have to take the square root of 285 equals W. Now, most teachers in most assessments do not want you to do 285 and take the square root of it, because that is an irrational number. You can't copy that number down. It never ends and it never repeats, and there's a number after this 2, and you would just be rounding, and we don't want to round. We want exact. So what you can do is you can break up 285. You can see if it can be simplified. So what do I mean is you want to break it into factors that are perfect squares. Okay, that's not easy. 285. What factor pairs of 285? So you can do prime factorization when we know 5 goes into it. So that goes in 5 times and 7? No, yeah, 7, right? Yeah, ugly. Apparently, that is going to be our answer. We did not look at that. Let's see what they want. I didn't even read the directions. What does it say? It just says solve. Not very exact. Now is it? Let's look at the answers. What do they give us? What? 17? Mr. Mac, do badness? Did I mess the first one up already? 64, 225, 6, 7. Mr. Mac, 4 plus 5 is 9. 289, Mr. Mac. Yuck. Silly man. 289. Oh, yeah, I think that's like 17. Because that is a perfect square. So we're not going to do that. We could have done 289. And we could have found prime factorizations. And I think it's just 17. I think 17 is really the only one. That's a really hard starting problem. But we could do this 2, 8, 9, square root, we get 17. 17 is prime, so there's not going to be any other factors of 289 besides 17. So that's not a real fun, friendly one. I like this one because students have to figure out what are the legs and what are the hypotenuse. Legs, hypotenuse. A, so your A are going to be your legs, A, B, and C. So you have y squared plus 12 squared equals 15 squared. So notice that in the first problem, our missing piece of information was the hypotenuse. It will change up. They will make a leg be one of your missing sides. So you get y squared plus 144 equals 225. We're going to subtract 144. We're isolating the variable. Y squared equals 81. 81, then we take the square root of both sides. And we know 81 is a perfect square. It equals 9. So that missing side length, the leg, is going to be 9. Now, 9, 12, 15, that's a kind of important number. You see 9, 12, 15. We see 8, 15, 17. These are called Pythagorean triples, meaning they produce whole number side lengths. And they are very unique and rare. And the Pythagorean triples they tend to be the problems that they give you because they want students to come up with a whole number. Hopefully at some point we will simplify and have to simplify a radical. But, and we know whenever you have 3 lengths, your longest side, 15, is always going to be your hypotenuse. The shorter 2 lengths will always be the 2 legs if you're given them. So here we have 8 squared plus x squared equals 18 squared. 64 plus x squared equals, I don't know what 18 times 18 is. 18 squared, 324, minus 64, minus 64. X squared equals 260. Take the square root. And 260 is definitely not a perfect square. That I do know. Square root of x squared gives you x. And now we can show an example. So we have 260. And I'm going to divide by 4. That gives us 65. Why did I choose 4 and 65? Why didn't I pick 2 and 130? 2 times 130 equals 260. But 4 times 65 is a much better pair. Why? Because 4 is a perfect square. 2 is not a perfect square. 130 is not a perfect square. So when I have the square root of 260, I can break it up into the square root of 4 times the square root of 65. And that is way more beneficial because the square root of 4 is a perfect square, so you get 2 rad 65. Why didn't I break 65? Because I know what 65 creates. That's 5 times 13. And neither of these are perfect squares, so we wouldn't be able to simplify this any further. So very important through experience. So this is the length of the missing side. Actually, I don't think it's x. Oh, it is x. Good. So the missing length, the leg, is 2 rad 65. You can't simplify that any further. Here are hypotenuse. So you have 12 squared plus 5 squared equals r squared. 144 plus 25 equals r squared. We're going to add those two together. You get 169 equals r squared. We're going to take the square root of 169. We're going to take the square root of r squared, and we get r, and I think that's 13. I think it might be 13. Yeah, that makes sense. 13 times 13, 169. Yeah, so that missing length, which was the hypotenuse, is 13. So the side lengths are 5, 12, 13. Oh, decimals. That must be hard. Nope, not hard at all. Keeping track, the most important thing is keeping track of which are your legs and which is your hypotenuse. M squared. And when we have this, we're going to look at this and we're going to see that 8 is in there. 0.8 is the same as 8, which is the same as 80, which is the same as 800. 8 times 8 is 64, and it's going to be 0.64. Why does the decimal go between the 0 and the 6 and not the 6 and the 4? Well, think about it logically. This number is less than 1, and it's really close to 1, and 1 times 1 would give us 1. If the decimal point was between the 6 and 4, that wouldn't make sense. So that logically tells me that 0.8, and there's 2 decimal places, so you move it 2 places to the left. We're going to subtract 0.64, and that gives us m squared equals 0.36. And hey, take the square root. We should know that that's going to be very similar to the square root of 36, which is a perfect square. So I'm going to assume that that is going to be 0.6. Let's check it out. 0.36 square root 0.6. Because 0.6 times itself would give you 0.36. So that side length is 0.6. And, oh, I thought we were done. We are not. X squared plus 12 squared equals 20 squared. X squared plus 144 equals 400. Minus 144 minus 144 gives us 256. Yes, square root x equals, oh, let's say that that's 16. $256. Why did I pick 16? Because I knew that 6 times 6 gave me 36 and would end in a 6. So that was sort of one of the numbers closest. I knew that 15 times 15 is 225, so I had to go larger than 15. We use logic, we use our memory, use logic, experience. That, kids, is the Pythagorean theorem. Those are the most basic problems that would be satisfactory on a work habits grade. Outstanding would be even more. You want to know what an outstanding one would be? Oh yeah, you do. You'd have something like this. You'd have x 2 rad 5 and something like that. Ooh. So you're squaring, and you're squaring. The real question is, the test here is, what is 2 rad 5 squared? 20. Because you have 2 rad 5 times 2 rad 5. 2 times 2 is 4. Rad 5 times rad 5 is 5. So that's why it equals 20, equals 36, minus 20, minus 20, x squared equals, oh my goodness, 16. How cool is that? I just made this up. And x equals 4. Boom, that is so cool. God is good. So that is a really, that just came up in my brain. Didn't even do that on purpose. On that note, we got to end. Have a great one. Good luck.